This video is recorded to help my students to understand how to estimate a population mean with sigma not known. We will use a homework example to demonstrate the method. Listed on left are the amount of mercury in parts per million or ppm found in tuna sushi sampled at different stores. Construct a 90% confidence interval estimate of the mean amount of mercury in the population. So on the left side here, in column A, list the sample data. Notice the sample data size is very small. According to book's requirement on page 371, we either need the population is normally distributed or sample size is greater than 30. Since the sample size is less than 30 and the problem did not mention that the population is normally distributed, we have to assume the population is normally distributed. Okay, actually the problem is not well established, so we need to add one condition: assume the population is normally distributed. So let's do this problem. First, we need to say how much is the sample size n. So, well, we should not count by hand. You can do the sample calculation, 9 minus 3 plus 1, which give you 7, or you can use Excel to count for you. You just simply say count. I want to count from A3 to A9, so give you 7. Then I need to calculate the sample mean, which is x hat. This will equal, we just use average function from Excel. You give the data range from A3 to A9. This gives you the sample mean. Then I need to calculate sample standard deviation. I use Excel stdv.s. S stands for sample from A3 to A9. This gives me sample mean. Now, the problem gives you the confidence level is 90%, so it's 0.9. So I can calculate alpha, which is 1 minus sample confidence level, which is 1 minus E8. This gives me 0.1. Now I need to calculate the critical value. This we will use student t distribution. So I will type the formula t dot inverse dot 2t. Now this formula requires this function requires two arguments. One is the probability, one is the degree of freedom. So this probability, this function will return the value t such that the px absolute value greater than t is equal to the probability you give to it. So the probability you should give to it will be 0.1. because absolute value of x greater than t is on the two tail, left side and the right side. The total is 0.1, the area. So degree of the freedom is the size minus 1, so which will be E4 minus 1. Okay, that will give you critical value. Now, I need to estimate, calculate the margin of error. The margin of error, I will use the formula, which this margin of error equal critical value, which is in E10, multiply the sample standard deviation, which we located in E6, divided by square root of the sample size. Square root of the sample size is in E4. So I calculate the margin of error. Now, let's do the upper limit of the confidence interval. That will equal x hat plus the margin of error. So it will equal E5 plus E12. Okay? Then the lower limit of confidence interval will equal the x hat, which is in E5, minus margin of error, which is E12. So now we make a conclusion. Your confidence interval is from 0.835 to 1.23. If you have any question, please give me an email.